Hi guys, so today we're going to be looking at Chapter 3, Section 6, Quadratic Inequalities, Part 2. So, solving quadratic inequalities in one variable. A quadratic inequality in one variable can be written in the following forms, where you have ax squared plus bx plus c is less than 0, ax squared plus bx plus c is greater than 0, ax squared plus bx plus c is less than or equal to 0, or ax squared plus bx plus c is greater than or equal to 0. So if I were to solve for the following, let's try out solving quadratic inequalities algebraically first. If we're asked here to solve for x squared minus 3x minus 4 being less than 0 algebraically, the way that we would do this is we would start off with factoring out our quadratic equation. We could do this either by using the x method or the box method, or we could use the quadratic form, x equaling to negative b plus or minus square root, and so on. So for this one, it seems like I could factor it. So I will use the x method first. We have here x squared minus 3x minus 4. And if I were to use the x method, I would get here a times negative 4, or 1 times negative 4, that equals to negative 4. My b value is negative 3. Then over here, I'm going to multiply the top and add the bottom. So I need two numbers that will multiply to get negative 4, and then two numbers that would add to get negative 3. I could use negative 4 and negative, well actually, let's use positive 1. Negative 4 times 1, that equals to negative 4. And then negative 4 plus 1 equals to negative 3. So once I do that, I get here x squared minus 4x plus 1x minus 4. And then from here, I'm just going to factor out two factors from each term, or each two terms that are given. So right here, take out an x, and I'm left with x minus 4. The other two terms, I can take out a 1, and I still get x minus 4. And so from here, I can take out the common factor, which is x minus 4, combine that together, and whatever is left over goes into the leftover factor, x plus 1. And this equals to just being 0. So when I'm finding my x values, I'm just going to split my factor into two different equations, x minus 4 equaling to 0, and x plus 1 equaling to 0. From here, when I solve it, add 4 to both sides, and I get x equaling to 4. On the other side, I can subtract 1 on both sides, and I'm left with x equaling to negative 1. So from here, I just need to start graphing it out to identify all my different variety of solutions that I could get. So right here, I'm just going to draw my number line. And I'm going to go from 0 right here, negative 1, negative 2. Over here I'll have 1, 2, 3, 4. And my last number will just be 5. So if I'm going to graph this out, I'm going to start off by graphing out my x equaling to 4. Which is right here. And then I'm also going to graph out my x equaling to negative 1. which is over here. I'm going to leave them empty because of the fact that if you see here, we have a less than symbol. If it was less than or equal to, or greater than or equal to, then I would have had to fill in the circles. After I do that, the next step that I need to do here is to identify and see if these points that are in the inside, in between the -4 and the -1 and the -4 are a solution. I also need to see if one of these points on the left side or on the right side are solutions. So let's start off first with -2. Let's see if any of the points to the left of -1 are a solution. If I plug in x equaling to -2 into the equation, x squared minus 3x minus 4, will this be less than 0? So if I plug it in, I have here -2 squared minus 3 times -2 minus 4 being less than 0. I get here 4 plus 6 minus 4 less than 0, and I get 6 is less than 0. So because this is not a solution, because it's not a true statement that 6 is smaller than 0, we can't say that -2 would be a solution. So that means that I'm not going to be drawing a line over here to the left. Let's try out 1. 1 is a point in the middle between -1 and 4. So let's see if that's a solution. So I'm going to try and see if x equaling to 1 is a solution. So I'm going to plug in x equaling to 1 into the equation, x squared minus 3x minus 4 being less than 0. When I plug it in, I get here 1 squared minus 3 times 1 plus 4 being less than 0. I get 1 minus 3 minus 4 less than 0, and that turns into being -6 less than 0. So this one works because the statement here that's provided, that would be true. So since this is a true statement, that means that any point in the middle area between -1 and 4 has to be a solution. So I'll draw a red knot line connecting them both to each other. Okay. Okay, cool. Let's check just to make sure that the outside isn't a solution. So if I want to check to make sure the outside of +4 is not a solution, then right here, I'm just going to check out x equaling to 5. So right here, I'm just going to plug in x equaling to 5 into x squared minus 3x minus 4 being less than 0. So I get here 5 to the power 2 minus 3 times 5 minus 4 less than 0. This turns into 25 minus 15 minus 4 less than 0. We get 25, or this turns into 10 minus 4 is +6 less than 0. And as we can see here, this is not true, so that means we can't draw a line going to the right of 5. So in the end, the only line that we really get here is the line in between -1 and 4. And so if that's the case, then my answer is going to be, the solution is any point that is between -1 and 4, which would be -1 being less than x, because it has to be any number that's bigger than x going this way, or it could be any number that is smaller than 4. Done. Okay. Let's check out the next problem. Okay, so right here, solving a quadratic inequality by graphing. Let's say we're asked to solve 3x squared minus x minus 5 being greater than or equal to 0 by graphing. So we're still going to try and find the x solutions here. And that also means that I'm still going to be using some form of factoring to factor out 3x squared minus x minus 5. As you can see, it's kind of hard to use the x method here, because if I did, we would get 5 on top, negative 1 on the bottom, and actually that wouldn't be 5, this would be 15, negative 15 on the top, because 3 times negative 5 gives you 15. There's no two numbers that would multiply to get 15 and add to get negative 1. There's only 3 and 5, 1 and 15. Neither of those work, so I can't use any of those. So because it's not really factorable, I'm going to have to use the quadratic formula, x equaling to negative b plus or minus the square root of b squared minus 4ac. And this is all going to be over 2a. Okay. So if I'm solving for this here, I'm just going to plug in my values. We get here negative b, which is negative 1, plus or minus the square root of negative 1 squared minus 4 times 3 times negative 5. And this is all going to be over 2 times 3. So when I'm solving for this, I get 1 plus or minus the square root of positive 1. Oops, sorry. Positive 1 plus 60. Okay. And when I solve for that, underneath is just positive 6. So I get here 1 plus or minus square root of 61 over 6. And so I get two solutions here. My first solution would be x equaling to 1 plus square root of 61 over 6. My second one will be x equaling to 1 minus the square root of 61 over 6. And so if I were to use my calculator and solve this, I get 1.47 as my first answer and negative 1.14 as my second. So if I were to graph this out on the graph, I just need to plot out the points for my x value. One of my x values was negative 1.14, so that would be somewhere like around here. This would be negative 1.14. And then the other one was 1.47. So 1.47 is somewhere around here. 0.47, comma 0. Once I have those 2 points, then you can kind of see where your parabola would be. I don't need to find my vertex because that's not really our goal here. Our goal here is to identify the different solutions of this graph. So I could just draw an imaginary parabola just for now, just to give us an idea of what our parabola look like. And it seems like we have a few points on the inside of the graph, like 0 and 1 and negative 1, that we could test out to see if any of these points are solutions. Or we could test out the sides to see if they're solutions as well, using like either negative 3 or negative 2, or 2 and 3. So let's start off first with the outside solutions. Let's see if anything outside of the parabola to the left is a solution. If I do that, I can test out negative 2. So right here, let's try out using x equaling to negative 2 and plug it into the equation. If I try out x equaling to -2, I get here, when I plug it into 3x squared minus x minus 5, I get 3 times -2 squared minus -2 minus 5. So this becomes 3 times 4 plus 2 minus 5. This becomes 12 plus 2 minus 5, and that equals to being 14, 9. So I get here 9 as my answer. And I want to see also if this is bigger than or equal to 0. Is this answer greater than or equal to 0? And the reason why, again, we're looking to see if this is greater than or equal to 0 is because that was in our first statement. We said that 3x squared minus x minus 5 is supposed to be greater than 0. So, seeing as 9 is a bigger number than 0, that means that this side of the graph is definitely a solution for this equation. Let's try out a point over here in the middle, such as x equal to 0. Let's see if x equals to 0 would be a solution. If I think that's the truth, then I need to plug 0 into the equation. 3x squared minus x minus 5 being greater than or equal to 0. When I plug it in, I get here 3 times 0 squared minus 0 minus 5 greater than or equal to 0. That becomes -5 greater than or equal to 0, which is a false statement. So because that's false, that means anything on the inside here is not a solution. They will all be incorrect. And then the last one, let's try out x equaling to 2 and see if that works instead. So here, if x equals to 2, and I were to try that out, we have here 3x squared minus x minus 5 being greater than or equal to 0. When I try it out, I get here 3 times 2 squared minus 2 minus 5 being greater than or equal to 0. When I solve for it, I get here 12 minus 7 greater than or equal to 0. This just becomes 5 greater than or equal to 0. Since that is a true statement, that means for sure everything on the right side is definitely a solution. And so we can see here that our image is definitely going to be the points on the left side and the points on the right side of the graph. We also have to include x equaling to -1.4 and x equaling to 1.47 as a part of our solution, since it shows right here in our statement from above that the equation has to be greater than or equal to. Because it's equal to, we have to include those 2 points too. And so when we write our answer, because they're split off in separate directions, we have to write that x has to be smaller than or equal to -1.14, or x has to be greater than or equal to 1.47, either or. Can't be in between. And that would be my final answer. So hopefully this helped. Good luck.